How do we get higher quality data faster and at a lower cost? And drones have been coming online. Every community, there's drone pilots that exist. These are just enthusiasts, right? And if they have an opportunity to actually earn some money to fly their community and contribute to the system, they love it. They're on board. They're sort of easy to find and access, connect to them, and very simply and easily and safely put them to work.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 447. I'm back after an extended stay in Amsterdam and Prague, ready to talk about drones and the people that use them for business, fun, and research. Today's episode is a landmark episode 2, part of an experiment in using AI to produce, streamline, and deliver the podcast content. Like all experiments, there may be some glitches, but hopefully you'll enjoy the content as always. Today we head to Vancouver, British Columbia, to hear from Bill Lakeland, CEO of Spexi, the world's largest decentralized drone imagery network. Spexi provides a scalable, sustainable, and cost-efficient alternative to traditional Earth imaging methods, with its network of drone pilots delivering detailed, near real-time imagery to support disaster preparedness, smart city planning, AI model training, and gaming applications. The network has mapped over 3.5 million acres in 200-plus cities across the world. Bill has over 20 years of experience in geospatial imagery, having led and exited as both a co-owner and vice president of 2 aerial imagery firms. Before launching Spexi, he spent 2 decades in traditional aerial mapping, operating fixed-wing aircraft with high-resolution cameras to capture imagery for municipalities and insurers. In this episode of the Drone Radio Show, Bill talks about Spexi's network of drone pilots and the company's efforts to provide high-resolution imagery of urban areas. But before we hear from Bill, I want to stress that your support is the heartbeat of my podcast. Every episode is crafted with you in mind, and your generous donations ensure I can keep delivering the content you love, whether it's a price of a coffee or a more substantial contribution. Every bit helps to defray the cost of production. Donate today and be a vital part of the podcast journey to greatness. To donate, go to droneradioshow.com/donate, and if you can please subscribe to the podcast on your favorite platform and leave a nice review. It really helps improve the podcast ranking among the many thousands of active podcasts today. And by the way, if you have a great story on the use of drones that you'd like to share in a podcast, contact me at randy@droneradioshow.com. So let's learn about a new and innovative way to acquire high-resolution imagery with Bill Lakeland of Spexi. Let's pick up the interview where I asked Bill to introduce himself.
Bill Lakeland, I'm the CEO at Spexi. I do a lot of aerial mapping, so my background is kind of flying the Earth from airplanes, and now we're doing that with drones and a decentralized network of drone pilots. These are incentivized like hobbyists and enthusiasts that currently we're incentivizing with cash to be able to capture data all over the planet to create a new image layer. So essentially, there's satellites and airplanes are constantly capturing imagery of the Earth. We're doing that now with a network of drone pilots, decentralized economy in a way, to be able to create a much higher resolution data set than what's currently available to the planet, that's more easily refreshable and sort of tasked on demand.
We'll dig a little deeper into all of that, but let's start with the company. What does Spexi do, and what is its mission?
Yeah, so Spexi is really a labs company. We build technology to be able to put a decentralized network of pilots to work. So my background, again, is in aerial mapping using aircraft. And how do you fly large geographies with a network of drones? That's the problem we've been trying to solve. How do we collect higher resolution data faster? Because we know everybody wants higher resolution, higher fidelity information, turned around faster and fresher. How do we do that with drones? And so we started building a software platform to be able to do that, to be able to make it very simple for consumer level drones and their pilots to be able to come on board in a system and very easily sign up and put that drone to work. And so this is all very automated missions where drone pilots fly up to hexagonal zones we call spexagons. They're roughly 25 acres in size. Pilots show up to those hexagons and they hit a fly button on their mobile app on their phone. It takes over the brain of the drone and flies completely automatically. So you can kind of think of it like an Uber for drones. I don't love saying that, but there is that sort of connection, except for our technology drives the car, it pushes the gas and the brake, it even starts the engine. And then, because of the case that it being drones, we're taking imagery, we also control the cameras, the exposure, even the time of day that they can fly so that it's not too dark conditions and things like that. So it's completely automatic.
It sounds pretty sophisticated. What inspired you to develop this type of technology?
I've flown airplanes for decades, honestly. A lot of what I've collected you would have seen on Google Earth, especially in North America. And, all our clients are always saying, can you fly lower? Can you get higher resolution data? You can fly these remote areas or, small towns that are far from major cities, and it just costs too much. It costs too much to send airplanes there. They're not scalable. You can buy another plane and another $1 million sensor because that's the cost of these sensors, and go farther, but it still costs a lot of money to send an airplane. Burns a ton of fossil fuels, produces a ton of carbon, and it's just not feasible and it's not scalable. So I was trying to really solve this problem. How do we get higher quality data faster and at a lower cost? And drones have been coming online. They're everywhere, even in the high Arctic. Every community, there's drone pilots that exist. These are just enthusiasts, right? And if they have an opportunity to actually earn some money to fly their community and contribute to the system, they love it. They're on board. They're sort of easy to find and access because they're on social media. They're tech forward folks, so they're on social media. We can connect to them and very simply and easily and safely put them to work. So it is a way for us to be able to essentially crowdsource, through a decentralized network of pilots to replace an existing system that's very carbon heavy, hard to scale. And now we can actually get meaningful data into a lot more users' hands a lot faster, especially when we're talking about, AI capabilities and needing, very rich base information for training models and these next generation systems that just have such a huge appetite for higher fidelity data to train on top of, right? And so we're able to sort of feed into that new machine.
You mentioned your system can actually take control of a pilot's drone. Does that mean it can fly autonomously once it's connected?
No, it is pre-programmed missions. So as I mentioned, we're actually leveraging the Uber H3 cell model. It's a geospatial reference plane. There's different sizes of hexes, but we're using a hex that's roughly 25 acres in size. And each hex that we call spexagons have an embedded flight mission in them. So it's a pre-programmed mission embedded into those hexes. So when the pilots actually show up to a hex, they select that hex on their mobile device. It pulls up an in-flight screen with already pre-planned mission baked in there, and they just hit a fly button. And the drone completely flies automatically. Our system, the software itself, kind of executes that mission in real time.
And when it's operating in a specific area, does the platform automatically handle all the local regulatory requirements?
Yeah, so we only light up spexagons to be flown in areas that have, like not in no-fly zones, not over airports and prisons and, sensitive areas. We don't actually put hexes there for the general network to capture. We can fly those areas. Everything can be flown, right? As long as there's the right approvals and process. We do leverage micro drones because one, they don't bother people as much as large drones. Like when you have large drones flying all over cities, the general public might get upset about that because there's a lot of drone activity. We're flying micro drones. These are below 250 grams. So they're very lightweight. So less risk to, other aircraft and humans as well, very lightweight drones. And so you can't see them or hear them really. They're not bugging people when they're up there. It's a big part of this network. And so we use that sort of system to kind of reduce a lot of risk, but also increases sort of access and availability of the harbor, meaning these things are everywhere. There's millions of them out there that we can actually connect to and put to work. And our system does all that itself.
Let's talk about the data side for a moment. Is the information you collect standardized so that it's consistent across different regions or countries? What types of data are you capturing?
Yeah, right now only scalable type data, so RGB data. These are micro drones, right? So they're only so advanced in what types of payloads they can carry. So this is like regular color imagery, which is by and large kind of the largest needed type of data anyways. Like what you would see in Google Earth, those types of products we collect and create, right? And so just at a much higher resolution for business systems. We're kind of flying at an altitude where we're not collecting personal information. We're flying at an altitude that airplanes can do, and they do fly at that resolution, but it's just too costly to do it. And so it's not a scalable solution where we are actually able to do that. So we're not actually too low that we're invading personal space or collecting personal information in any way, shape, or form as well. So you can't read license plates and house numbers and things like that.
Who are some of the customers currently using your data? And what kinds of applications are they using it for?
Yeah, so I mean, we feed straight into city GIS, right? So like your background is usually what I would have supplied to, from the traditional sense with airplanes. So we do already work with a lot of cities and stream our data into a GIS as either ortho photos, like what you would have used of the city, so like 2D maps like you see in Google Earth, streaming those in, or like static images. So we call them standardized images. So if a city wants to look at a certain address, they can punch it in and they'll just get all the photos that are looking at that address at their native resolution. And they can also create downstream products from those images as well. So we can feed them into different sort of technology solutions very quickly so that they can create more bespoke models from those images. And so cities are one. Cities love it because we're paying their citizens to collect the data for them, right? So the money that cities are actually giving us, we're giving right back to their own citizens to collect it. And we're giving them a software technology to be able to stream that data into their GIS. So it's a bit of a win-win. But when we get enough cities, then we get interest from, utility companies of broader geographies. So, hydro, all these sorts of different utility companies, telcos are now interested because we have a broader geography. Insurance companies for faster underwriting, safer response to events. So once a network's up and running, there's no one that can respond as fast as we can. We've done this a number of times in like fire situations and flood situations and other kind of emergency situations where we've been able to capture the areas much quicker than you could any other way. And so we're able to help first responders and give visibility into what has occurred in as close to real time as possible, which is having a huge impact in, insurance use cases and safety use cases at first responders.
Is artificial intelligence integrated into your platform? For instance, in how images are processed or analyzed?
Yeah, and that's kind of where we're seeing things going now. And that's sort of probably our biggest use cases unfolding in real time is as we're increasing geography, we're amassing such a large high resolution data set of, built up Earth that retraining systems that are already looking for, so say city operations, there's tree bylaws. I just show me the trees that have been removed in the last 3 months. Show me all the asphalt roof shingles that have 20% life remaining in, the metro area. How many cracks per square meter, or how many areas in the city have more than 10 cracks per square meter on the sidewalks? You can start to train these systems to look for, what normally human would be coming through the data to look for. And there's just like unprecedented amount of use cases coming out of this because it's streamlining kind of business operations, right? Which is one of the big things we're trying to unblock in this process. So, satellite and aircraft data for insurance companies might show, a pine tree is more flammable than a fir tree and it's within 10 meters of the house, right? But the fidelity of that pine tree or the confidence of that being a pine tree might be 50%. Where now with our data, it's like 99% confident that's pine tree. And so there's just little bits of elements that, our data can extract or can be extracted from our data to produce higher accuracy AI outputs, essentially. And so when you start building a higher resolution kind of model of the Earth, there's companies that now are taking this to the next level where they're starting to build like large geospatial models. So like what an LLM is for language, this is like that in a geospatial world. So business systems can actually interact with a 3D world for kind of closer real-time operational intelligence, right? So humans and robots, they're constantly moving around the Earth, more robots. And I'm talking not just cars and drones, but like snow removal, sidewalk devices and delivery systems. And, all these different things are going to be moving around the planet. The more efficiently they can do that, the better. And with a real high fidelity digital world as part of their kind of brain and the reference system helps reduce risk and speed up efficiencies and all these sorts of things, right? As well as training augmented objects. So if you're trying to, go to the nearest Starbucks and you want to follow a digital bunny and you put your glasses on and you can just follow a bunny to the nearest Starbucks instead of like looking at a map. That bunny needs to be trained to know how it moves through the real world. It needs to be trained on a digital world. And that digital world needs to be very accurate and up to date. Otherwise, that bunny is going to lead you into, a bench or off a curb or, whatever, right? So for training these next generation augmented objects and creating kind of more accurate worlds in that way is a big part of what we're building.
How do you decide which areas to map next? Do you follow a set strategy, or does it depend on where you have enough pilots ready to fly missions?
Yeah, I mean, we definitely have more requests from pilots to fly new areas than we just go ahead and fly just yet. So we haven't completely opened up the network to hit supply before we have demand signals and sort of building up that engine, like enough cities to work into utilities and, building out, AI models and things. Like we're a Canadian-based company. We're based out of Vancouver. It's where we started. So North America is our backyard, and kind of nailing what this is here, it gives us insight because everywhere in the world has the same data, access to data, like they have the same types of sensors flying over their cities. All that data is kind of the same. So they also have the same sorts of problems. So however we're building a system here is actually very translatable everywhere else. And so we've sort of built out the playbook. We have enough critical mass of buyers and customers in North America. We can then start to lead supply into new countries and territories. So, for example, we have a large client that really is interested in Sao Paulo. But we're not just going to go to Brazil to fly to Sao Paulo. We'll just fly every city in Brazil now because we've seen how that demand plays out in that way. There's enough users in Brazil to start that going. But building that in North America is really core to what we've been doing. And we're kind of now in that process of expanding into new countries like the UK and Japan and looking at Brazil now.
How does someone become part of your network? Is there an onboarding or certification process?
Yeah, it's a good question. So right now, pilots are paid in cash. There is being launched what's called the Layer Drone Foundation. So this is like a decentralized kind of blockchain-enabled network. And so pilots are actually transitioning to Layer Drone as we speak. So that's where the protocol, the architecture, a lot of the technology will live to sort of unblock. And we can actually, supply can be scaled much more quickly. And so layerdrone.org is now the landing place for the pilot community to sort of eat, sleep, and breathe, get onboarded, see what areas are open for flights, and then be able to sign up and contribute and find out when we're coming into their areas. So that's sort of the landing page and the informational part of that. Layerdrone is still using and will be using for the foreseeable future technology from Spexi to be able to capture. So like Spexi will have an app that is powered by the Layer Drone network of pilots to collect data that Spexi is most interested in to be able to create this layer, the standardized layer of the planet, right? But other companies, for example, that have an app could also connect to the Layer Drone pilot network and put them to work in collect imagery in a way that makes sense for what it is that they're trying to do. So maybe they're trying to do like 3D models of monuments or, public spaces that are, key areas that they wanted a higher resolution that we're doing as a standardized data layer, right? And so then other companies and enterprises can actually go straight to the network and put pilots to work in that way.
Once a pilot is selected, what's the process for ensuring the data they collect meets Spexi's quality standards?
So inside those hexes, the spexagons that I mentioned, we can actually have the drone do whatever we want. Like we can pre-program missions in a very unique way, but we don't necessarily do that. We're trying to keep the drones doing things very standardized so that the data we're collecting here is the same we collect in Reykjavik and South America and Australia. It's a very consistent like data layer. So they're always flying at the same height, performing the same types of activities. But we do have basically 3 different mission types that we embed into them to perform that work. And we don't necessarily plan too soon to add complexity in the system, like fly lower, do orbits, like doing these different mission types, right? So we kind of stick to what that is, and those missions are set in a way so that we're collecting this very standardized layer of data.
From a pilot's perspective, it sounds like they just upload their mission plan, launch their drone, and the system takes care of the rest. Is that right?
They don't have to know anything about those details. That's completely handled by our system. The friction is totally removed. The biggest part that we also have to make sure is because we are using, decentralized pilots and their hardware, that the data doesn't get tampered with at all. So while the drones are actually collecting the imagery and the spexagons, we are generating soul-bound NFTs to a blockchain wallet for those pilots, right? And so the data that's sort of being collected, encrypted, and authenticated in the moment of capture, because our system is actually flying the drone in real time. When they go to upload those images, they have to match. And if there's been any tampering, say I want to change the date so maybe I can get paid for the same image twice, that won't work. And that's been foolproof to date. It's worked really well. There's also a bunch of other processing mechanisms in the back end to triple confirm that. So it's all very automated, simplified. So literally when the pilots go to upload the data, they can just drag in the entire data that they have on their card. That could be images of their family, or it could be like Word documents and all these different files. And it's only going to take those authenticated images that were collected in real time and matched through that sold on NFT process.
How does payment work for pilots? Do they get paid once their data is uploaded and accepted?
So right now, until Layer Drone is completely, on its own and takes over the pilot network, which will be a token form of payment. Currently, it's paying in cash, and pilots actually have Stripe connected through the mobile app as a payment mechanism. So, we're paying between $5 and $15, and in that effect, it ranges depending on the mission type and the complexity of the area, or how quickly we need the data back. And they're earning 500 or more a day in some cases, off of $600 drones. So the capital expenditure is pretty interesting for the network that we're running here.
Bill, is there anything that we missed that we should talk about?
I've been working on this for a long time, from aircraft, and trying to figure out how to improve this system, get data into people's hands that can benefit from it, business systems that can benefit from it. Resource our world better, more efficiency and less waste. And there's, operationally speaking, there's just so much advantage of using high resolution aerial imagery, right? And we've created and proven now to have created, because we've flown, over 150,000 missions in just a little over a year from now, back from now. And we've proven that we can actually collect this data at scale. And we're by far the largest standardized image layer of the planet at this point from drones. And so now with this new way to be able to collect data, and with blockchain as a way to be able to scale it like we've never seen before, blockchain technology adding into the system is a way to actually prove the authenticity of the data. It's enabled to access pilots faster. It's liquor payment rails. It's an ownership economy. There's more meaningful contribution from the pilot community that we can actually scale across borders faster, so we can actually get this data in at a faster rate. For the reasons that AI can now actually take all that data and work through it much more meaningfully than humans could in the past. And so because AI is at the point now where it just needs higher quality data to create higher accuracy trained models, we're feeding into this sort of new world of information at a rate that we can actually keep up with it. So these two things are actually like the flywheel starting to spin, because the amount of data that we can actually feed into the system that it desperately needs, but we also need it because it's our demand engine. These things are now starting to like flywheel and spin together, which is kind of this incredible point in timing that, doesn't come along very often. I've been working my entire career in this field, and I've not seen this confluence of technologies coming together and timing for something like what it is that we're building ever before. I've never seen this. So that's to me the most exciting part. And the pilot community and leveraging citizens and putting the work in a meaningful way to collect data that's actually valuable and useful and sort of gives back to the planet, because we're reducing carbon from the status quo. We're creating information that's actually like helping humans and robots move around more efficiently, helps utilize our planet's resources so much better. And that's the part where I'm like most affected or moved by what it is that we're doing, because to me, it's always been a part of my ethos of why I've been doing this in the first place, right? So now we're actually seeing this really scale and value, and it's an exciting time to be in this space.
And for my final question, Bill, what's next for Spexi? What can we expect to see from you and your team in the coming year?
Yeah, well, so Layer Drones is coming online as a separate entity. It's going to power sort of Spexi's technology. Spexi is really going to be focusing a lot of R&D in extracting more information from the data we're collecting. So the data coming out of layered drone is being sort of collated, standardized by Spexi, and processed in a way that's sort of deliverable to like the Ubers and the Googles and the Metas and the OpenAIs and all these kind of folks to start training on. But Spexi is also working on some of those things themselves. So like the equity value in Spexi and the data that's coming out and helping kind of tune some of these next generation large geospatial models in a way that kind of helps business systems operate more efficiently, like I had discussed earlier, is really a lot of what Spexi is going to be focusing on over the next year or two. And really excited about putting our R&D dollars into, turning this data into really valuable insights that humans don't necessarily look at all. It's all systems and computers, right? This is like the highest resolution image layer of the planet that nobody's actually really going to see. It's just being queried constantly and accessed constantly, just like an LLM. You're not seeing what's going on in the back end. It's just a bunch of data that's being responded to, right? And so this building what that is, I think, is the core of what's next at Spexi.
That's it for episode 447 of the Drone Radio Show. I hope you enjoyed hearing from Bill Lakeland of Spexi. I want to thank Bill for taking the time to speak with me. If you want to learn more about Spexi or want to connect with Bill, check out the webpage at spexi.com. If you like the Drone Radio Show, then please subscribe and share, write a glowing review. And if you'd like to donate to keep the podcast going, go to droneradioshow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Goers.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.